Hello, in this video we are going to be graphing sine and cosine functions. Okay, so when we talk about graphing functions, we're going to be talking about transformations, that being stretching them vertically and horizontally, translating them up, down, left, right, and reflecting them vertically across the x-axis. We're going to be exploring these characteristics of both the sine and cosine functions. Okay, so first let's just explore what a typical sine function looks like. So we're just going to use our calculator to fill in this table, right? Make sure your mode is set to radians rather, because 2 pi, all of these are in radians, not degrees. So if you want to, please take a moment to pause this video right here and copy down this table into your notes, and then use your graphing calculator or use Desmos or use any scientific calculator that has sine, cosine, tangent functions in them to fill in this table. Okay, when you fill in this table, when you enter sine of negative 2 pi, you'll find that that has a value of 0. Okay, when you find sine of negative 7 pi over 4, you'll find that that has a value of 0.7071. Okay, when you enter sine of negative 3 pi over 2, you'll find that that has a value of 1. And then sine of negative 5 pi over 4 has a value of 0.7071. And we're actually going to be doing a lot of repeating. Sine of negative pi is 0. Sine of negative 3 pi over 4 is going to be negative 0.7071. Sine of pi over 2 is going to be negative 1. Here we're going to have negative 0.7071, and here we're going to have 0. Sine of pi over 4 is going to be positive 7.7071. Sine of pi over 2 is 1. Sine of 3 pi over 4 is 0.7071. Sine of pi is 0. Sine of 5 pi over 4 is going to be negative 0.7071. Sine of 3 pi over 2 is negative 1. Sine of 7 pi over 4 is negative 0.7071. And sine of 2 pi is 0. And then lastly, sine of 9 pi over 4, if we extend this one more fraction of pi, we get 0.7071. So you'll notice there's a lot of repeats in here. This is a very cyclical pattern, okay? If we actually plot these values onto this graph down here, right? 2 pi, negative 2 pi, and 0 is going to be here, okay? Negative 3 pi over 2, that's my next x value. My next x value, negative 3 pi over 2, my function is up at 1, so that's approximately right here. And then my next value is negative pi, that's down at 0. My next value is negative pi over 2, so I go to my table, x is negative 2, y is negative 1, that's going to be down here. My next value right here is when x is 0. So when x is 0, sine of 0 is 0. My next value here, x is pi over 2, so my table says the y value is 1. My next value here is pi. I go to my table and it says that the y value is 0. And you can see that this is a pattern, right? My next x value is 3 pi over 2. I go to my table that says it's negative 1, so that's going to be down here. My next x value is 2 pi, which is 0. That's right here. And my next x value is 5 pi over 2, which is not included in my table. Okay. Now, if I include these other values in my table, 0.7071, negative 7 pi over 4, that's actually going to be halfway between negative 2 pi and negative 3 pi over 4, and it's going to be pretty high up here. Okay. And then I've got that value repeated again. right? So that's going to be halfway here and up here. I've got the negative of that value. So negative 0.7071, halfway between negative pi and negative pi over 2, and clear down here. And again, I've got that value repeated, so we've got a nice pattern going on. That's going to be right here. Okay, I come over here to pi over 4. Pi over 4 is right halfway between 0 and pi over 2, and my x value is 0.7071. There it shows up again. Okay, I go up to 1, I come back down to 0.7071. There it is again. And then my negative values, when halfway between pi and 3 pi over 2, I've got negative 0.7071, so that's going to be down here. And it repeats again, so that's going to be down here. And then I've got this 9 pi over 4 is going to be halfway between 2 pi and 5 pi over 2, so that's going to be up here. Okay, and if we graph all of those, you'll find this very nice wave pattern, right? Going up, coming down, going down, turning, and going back up. And you'll notice in this wave pattern that it's not ever pointy, right? It's very smooth and curved, much like if you gently disrupt water in a pond, how the surface of the water is just wavy. It's not pointy in any place. We've got very nice curves going on. Okay. If we do the same thing for our cosine function, you're going to notice that the same values show up. Okay. If you do the cosine of negative 2 pi, you're going to find a value of 1. The cosine of negative 7 pi over 4, you're going to find a value of 0.7071. The cosine of negative 3 pi over 2 is going to be 0. The next cosine, you're going to find negative 0.7071, and then negative 1, and then negative 0.7071, and then 0, and then 0.7071, and 1. And come back down to 0.7071 and 0, and negative 0.7071 and negative 1. And this is also a very nice pattern. It uses the same numbers over and over and over again. And 0 and 0.7071 and 1 and 0.7071. This time, if you were to plot these points on this axis that we've got at negative 2 pi, your function is up here at positive 1. Okay, at negative 3 pi over 2, our table says the function comes down to 0. At negative pi, the table says we're down at negative 1. At negative pi over 2, we go to our table and it says the function has a value of 0. When x is 0, I go to my table and it says the y value is 1. When x is pi over 2, I go to my table and it says the y value is 0. When x is pi, I go to my table and it says the y value is negative 1. When x is 3 pi over 2, I go to my table, it says the y value is 0. When x is 2 pi, I go to my table, it says the y value is 1. Okay, and then again, I can plug in these other points, right, and see that just like in my sine function, I've got some really nice rounded cyclical type smooth curves going on. So I start up here, I come down, I go through the x-axis all the way down to negative 1 and turn nice and smoothly. We don't have any points going on. There's no sharp turns. It's all nice and smooth, right? So we keep going back up, and we could repeat this as much as we wanted to actually, and it would come down like that, and this would come down on this other side, and we would keep going. Okay, so let's talk about some key characteristics and differences in our two functions. Okay, we have our sine function. Sine of x contains this point 0, 0. As the parent function, sine has the point 0, 0. Whereas for cosine, the parent function, when x is 0, y is 1, right? So that's a key difference to notice. Okay, some similarities that it has is this fact that the period, so when you start one wave in the middle right here and you go up and you come to the middle again, you go down and you come to the middle again, we call that one period because we could take that and make a stamp out of it and create the whole entire graph repeating this piece over and over and over again. So that's one period. It has a length of 2 pi as the parent function. Okay, if we start with our cosine function, when x is 0, right, our graph starts high, comes down in the middle to 0, y is 0, comes down farther to y is -1, then it turns and goes back up to y is 0, and then it goes up and it finally finishes at y is 1 again. So this period has a length of 2 pi, but the stamp would look different because it would start high, come down low, and finish high. So that is one period length from 0 to 2 pi. The length of it is 2 pi, and we call the length of it the period. All right, so in this slide, we talk a lot about vocabulary. So if you are concerned about remembering your vocabulary, I highly recommend you to pause the video right here and copy down especially these key terms. Amplitude, which talks about how tall a graph is. Periodic, meaning that it repeats exactly the same pattern over and over again. Your pattern never changes, it never gets bigger or smaller, it never goes out of the normal. It's exactly the same pattern over and over again. The shortest part of that pattern is called a cycle, and the length of that cycle is called a period. Okay, so let's talk about ways that we can change the way our graph looks. First, we could change the graph using something that we call an amplitude. The amplitude A is a multiplier in front of your sine or cosine function. That will be a vertical stretch or shrink, right? So vertical, it's either gonna make it taller or it's going to squish it and make it shorter, right? The period, on the other hand, talks about the horizontal stretch, and that's actually multiplied inside of your function with your x. Okay, that's your period. And basically what this is talking about, b itself represents the number of new cycles happening in 0 to 2 pi, okay? So you can find out how long one cycle is, right? The period length, how long one cycle is if you take 2 pi and divide that by the absolute value of b. Okay, so let's apply that if we can. We have this first function that we want to graph is identify the amplitude and period of g of x equals 4 sine of x, then graph the function and describe the graph of g as a transformation of the function of f of x equals sine of x. Okay, so the amplitude is something that we're going to get directly from multiplying in front of our sign, the amplitude is 4, right? So that tells me right away on my graph, here's 0, 0, 1, 2, 3, 4. This is how tall the graph is going to be. And then I mirror that down, negative 1, 2, 3, 4, and this is how low the graph is going to go, right? That's what the amplitude means. It stretches it taller and down farther lower, okay? The period, you'll notice there's no number in front of the x, so the period is going to be our standard 2 pi, okay? So I know that because this is sine, I'm going to start here. In the middle, I'm going to come back down to 0. And at the end, I'm going to come back down to 0. Okay? Halfway between the beginning and the middle, I'm going to be at the maximum point. Okay? Halfway between the middle and the end, I'm going to be at that minimum point. Okay, so if I want to graph this, I'm going to make sure that this is smoothly curved up at the maximum, come down to 0, come down to 0, make sure that this is smoothly curved, and go just like that. Okay, so this has a transformation of basically just being stretched vertically, stretch vertically by 4. It's not going to have the period changed. Okay, so let's look at that on a graph that's been graphed by a computer. And we have, you can see that we have this right here. We're going from 0, 0 up to a maximum height of 4, back down to 0, to a minimum, the bottom is negative 4, and back to 0. Okay, so we've stretched it vertically by 4. The length of one period has not changed. Okay, if we want to compare that to our parent function, just sine of x, here this red one in here is sine of x, and you can see even more clearly now that this amplitude has been stretched taller and stretched lower. The amplitude has changed, okay? We have not changed from the beginning of one cycle to the end of one cycle. Okay, now let's look at this example here. We have identify the amplitude and period of g of x equals 1/2 cosine of 2 pi x. Then graph the function and describe the graph as a transformation of the parent function. Okay, so again, we're going to look for the amplitude. We're going to take this number in front. So the amplitude is 1/2. That means that if this is 1, right, I'm not getting any taller than 1/2. And I'm not getting any lower, any shorter than negative 1/2. Okay, now for this period right here, this 2 pi is my b. Okay, so for the period, I want to take 2 pi over the absolute value of b, which is going to be 2 pi over 2 pi. So my period length is going to be 1. Okay, now I need to estimate approximately where is 1 in this graph. Okay, well, if this is 2 pi, then this right here is pi. That's 3.14. Okay, here is going to be about 1.7. So a little bit shorter than that. I'm going to have one period ending approximately right here. Okay, so if my graph itself is starting high and ending high and halfway between those coming down very, very low, then it's going to look a little something like this. See how it's both shrunk vertically and also shrunk horizontally, right? So the top of this, we're shrinking it down. The bottom of this, we're shrinking it. but we're also shrinking the width of one cycle, right? It only has a length this time of 1. Okay, so if we let a computer graph it, you can see this has a height of 1, or a height of 1/2. The bottom is 1/2. And then from this maximum point right here to this maximum point right here is going to just be 1, right? So this has an amplitude of 1/2, a period of 1. It's been transformed vertically, it is flatter by 1/2, and horizontally it's squished together by 2 pi into a period length of 1. And if we compare that to the parent function of cosine, okay, this black line is the parent function of cosine, you can actually see even more clearly that for our period, we're starting here. So from here to here is 1, 2, down up 3, down up 4, down up 5, down up 6, and a little bit more. And that little bit more is going to be the rest of 2 pi. So we are getting 2 pi worth of full complete waves in what would have normally been the period of our parent function, right? From 0 to 2 pi. All right, so these steps right here, if I were you, I would copy these down. We want to graph y equals a times the sine of b times x minus h plus k, where a and b, we just talked about those. A is the amplitude, and b changes your period length. X is going to change, or x minus h, so that h is going to be a horizontal shift. So that's going to be moving it left or right. And then k right here is going to be shifting what we call the midline up or down. Okay, if you want to take a moment and pause the video and copy those down, I would strongly encourage you to. Okay, so for our next example, we're going to just graph g of x equals 2 times the sine of 4x plus 3. Okay, so I'm going to look at my amplitude. My amplitude is always this number multiplied in front of sine. My amplitude is going to be 2. Okay, my period is going to be controlled by this 4 right here. So my period, if I take 2 pi and divide that by 4, I get that the period length, one period, happens between pi or 0 and pi over 2. Okay, and then lastly, not in parentheses, I have this plus. So that means I'm going to shift the midline up 3 units. Okay, so let's put all of that together. Here's my 0, 0. If I shift my midline up 1, 2, 3 units, that means that the midline, the middle of the graph, is going to be right here. And from that midline, I'm going to count up and down 2 units. So up 2, this is going to be the maximum that my graph will reach. And then from the midline down 2, this is going to be the minimum that my graph will reach. Okay, and then my period length happens between 0 and this is pi, so cut that in half again. This is going to be pi over 2. Okay, we're talking about sine, so that means that I'm going to start in the middle, end in the middle, halfway between those be in the middle, halfway between the beginning and the middle, I'm going to be at my maximum. Halfway between the middle and the end, I'm going to be at the minimum. And then I want to connect those with an attempt at a smooth curve with no points. We don't want any harsh points, right? And I would keep repeating that curve over and over and over, but that would be a basic stamp. Okay, so let's look what it looks like when a computer graphs it. Looks a lot like this. Okay, so as you can see, we're going from the midline at 0, up, back to the middle, down, back to the middle, and that value right there is pi over 2. This is pi, this is 3 pi over 2, and this is going to be 2 pi. Okay, so you can see that we have from the middle to the top, it's stretching up 2 units. It has a period from 0 to pi over 2, and it's been transformed up 3 units. So the midline right here is at 1, 2, 3. And if we compare that with our parent function, you can actually see even more clearly this 4 right here means that I have 4 waves happening in what would normally be 0 to 2 pi. So let's count them. So from here to here to here, that's 1. Do it again, that's 2. Do it again, that's 3. Do it again, that's 4. So this 4, I have 4 new waves happening within my parent function. All right, let's do it again. This one we want to graph a horizontal translation. Okay, so if I look at my graph, I see this 5 in front that tells me the amplitude is 5. Okay, I see this 1/2 right here that tells me that the period 2 pi divided by 1/2 is really the same as 2 pi times the reciprocal, 2 over 1, equals 4 pi, right? So one period takes up the entire width from 0 to 1, 2, 3, 4 pi, okay? I have inside parentheses this minus 3x. So this minus 3x right here says that it's minus, so it's going to be shifted to the right 3 pi units. So we're going to shift this right 3 pi. There is nothing being added or subtracted outside of the parentheses, so it's not going to shift our midline up or down, okay? So if we get rid of these and start with our horizontal shift, we're going to shift it right 1, 2, 3 pi, okay? From there, I'm going to count 4 pi for my period. 1, 2, 3, 4. This is how long from here to here. This is how long one period needs to take. Okay, and then finally my amplitude of 5. That means that the maximum is going to be up here at y equals 5, and the minimum is going to be down here at y equals negative 5. Okay, since this is a cosine function, that means that it starts high, hits the middle, goes down low, hits the middle, and goes back up high. Okay, so if I graph that, right here, if I graph that, then right here, at the start of my period, we're going to start high, and we're going to, at the end of the period, end high. So that's this and this. And then halfway between those, we're going to hit our minimum. So halfway between 3 pi and 7 pi is going to be 5 pi. We're going to hit the minimum down here. And then halfway between a maximum and a minimum, we're going to hit the midline, or in this case, 0. So let's plot those. Halfway between 3 pi and 5 pi is 4 pi. We hit the middle. Halfway between 5 pi and 7 pi is 6 pi. We hit the middle. Okay, so if I graph those with a nice smooth curve, we come down, we round it, we go back up, and we round it. Okay, so let's see what kind of a better job a computer do. It's going to look something like this. So we're starting the beginning of our period, we're starting up high, hitting the middle, coming down low, hitting the middle, and ending up back high. And that's going to be one period. It has a length from 3 pi to 7 pi. This right here is going to have a period length of 4 pi. Okay, and then here is our, in the black right here, this is going to be our standard cosine function. Okay, and this makes it a little bit more obvious the fact that there is only 1/2 of a complete wave within 0 to 2 pi from the parent function. So if I go from 0 to 2 pi, you can see that that starts in the middle, goes down low, and ends high, and that's only half of a wave. I would need to double that and go up and then back to the middle in order to complete my wave. All right, and then the last thing to talk about is if we want to reflect sine and cosine functions. We're going to be limiting this to reflecting it just over the x-axis, so up or down. Okay, my sine function, if I reflect that, it's going to, instead of starting at 0, 0 and going up, it's going to start at 0, 0 and go down. Okay, my cosine function, if I reflect that, instead of starting the function up high at 1, we're going to start the function down low at -1 and go up and then down and down. All right, so let's try this graph. We want to graph g of x is -2 times the sine of 2/3 x minus pi over 2. Okay, so this negative right here says the amplitude is 2 and we have a reflection of the sine function. So we're going to start in the middle and go low. Okay, the period right here, 2/3, if we take 2 pi and divide that by 2/3, that's really like saying 2 pi times 3 over 2. And you'll notice that the 2 and the 2 cancel out. So our period length is actually 3 pi. And then finally, this minus pi over 2 says that we are shifting this pi over 2 units to the right. Okay, there is nothing added or subtracted after our function, at the end of our function, so we're not going to shift the midline up or down. Okay, so first let's start with shifting this thing to the right, pi over 2 units. Okay, so I have labeled here 0, here's pi. Halfway, that's going to be just pi. And then halfway again, this is going to be pi over 2. Okay, so that's pi over 2. 2 lines represents pi, 1 line represents half of a pi. Okay, and then if I look at the period length of 3 pi, remember 2 lines represents 1 pi, 2 lines 2 pi, 2 lines 3 pi. So from here to here is going to represent 1 period length. Okay, and then finally, let's pull in the amplitude. The amplitude is 2, so that means that my maximum are going to be up here at 2, and my minimum are going to be down here at y is -2. But we have to remember that we have a reflection in there. Okay, so our typical sine function is going to start in the middle, go up high, go back to the middle, go down low, go back to the middle, except that we are reflecting this. So instead of going to the maximum, we're going to go down and then back to the middle and then up and then back to the middle. So we're going to start at 0, 0. In the middle, we hit 0. At the end, we hit 0. halfway between our zeros, we're not going to go high. Halfway between our zeros, we're going to go low and hit our minimum. Halfway between our zeros, we're going to hit our maximum. And then when we graph that, we draw a nice smooth curve. And we end up with something looking a little like that. We could take that as a stamp and repeat it, and it would come out here and go back up, and then go up here and then come back down, right? Okay, let's see a computer graph it better than me. And here we go. We have, starting at pi over 2 with an amplitude of 1, 2, 3 pi, or with a period of 3 pi, okay? We have, this is reflected vertically, so it's going down before it goes up. And our amplitude, so the highest that it reaches is 2, and the lowest that it reaches is -2. Okay, and if we want to compare that with the graph of just our parent function, remember this parent function right here is just y equals sine of x. Okay, you can see that this has been shrunk just a little bit tighter, right? Or this green one has been stretched just a little bit longer, rather, and it's been stretched a little bit taller, so that the maximum and the minimum go farther away from the midline. All right, thank you for watching. And I know that a lot of you do not have a TI graphing calculator for you to use at home. However, I want to remind you, you can always use desmos.com. Okay, it's very simple. You just type into the little box if you want to click this little globe, or if you want to go to www.desmos.com/calculator. That will pull up a graphing calculator, and you can make your graphs just as nice as my computer-made graphs that I used for these notes. Thank you for watching.